present in this level. So now I pick an action for supporting not clear P, I pick an action for supporting hand empty, and then I got this action into the plan now. Now its preconditions, hand empty and clear B, become sub goals here. I have to pick them, actions, and continue back. Yes, sir?
Are these actions that support the goal proposition, are those chosen arbitrarily, or is there a methodology?
Okay, so that's a good question. So the question is, how do I choose these actions? Now, the simple question to ask is, how hard is it to find optimal relaxed plan? That means, so in this particular case, let's see, in this particular case, right, I use stack AB to support not clear B, but I could have, for example, used put down B to support hand empty. In which case I would have gotten a longer relaxed plan. Right? And by being greedy and reusing the action I already chose to support the rest of the goals, I got a slightly shorter relaxed plan. The question is, so what I did is greedy relaxed plan computation. The question is, how hard is optimal relaxed plan computation? Unfortunately, just like everything else in life, that's again NP hard. Okay, so if you want optimal relaxed plan, it's NP hard. Now, what goes wrong if you don't get optimal relaxed plan? If you get non-optimal relaxed plan, that means the length of the plan could actually be longer than the shortest plan you need to reach the goal, assuming no interactions. Now, if in fact this is one of these worlds where there are no interactions to begin with, then in fact you would have overestimated the heuristic. Okay? So, admissibility is one of those properties which it's like, it's a useless property, as you will learn to see. It's pretty useless in practice, but it's great in proving that admissibility is violated, because all it needs is one example where it is violated and it's violated. Yes?
If you use persistence actions whenever possible, then wouldn't that make it be admissible?
Think about this. Actually, it's not enough. Okay? So what you are doing here, so the question is this. The question ultimately is, so optimal is NP hard. Okay? And yet I kind of showed you one which I said is greedy. Why is greedy any better than optimal? I understand the quality isn't going to be good, but at least is the cost of computing greedy cheaper? It is indeed cheaper, because once I pick an action here, I will never have to come back and remove that action and pick another action at this level. Okay? Not at least once I pick a set of actions in this level, I will never be forced to backtrack here. If all I care about is a relaxed plan, I can pick any set of actions which support this, any set of actions which support their preconditions, any set of actions, etc. And I'll never have to backtrack. And not having to backtrack is a huge advantage. To understand how huge an advantage this is, think about, and I'll make you think about it again next class, but think about, suppose you have this planning graph now with mutual exclusions too. Now, one interesting thing is, when you have planning graphs with mutual exclusions, nobody talks about relaxed plans. Why? Because there ain't no relaxed plan. Because basically the set of actions that you pick here might lead to sub-goals which will become mutually exclusive. And so you have to come back and change the actions here, and then go back forward again. In fact, original graph plan algorithm can be thought of as trying to find relaxed plan on a planning graph with the minimal number of mutual exclusions. Okay? If in fact, you do the minimum number of mutual exclusions, or if you just mark only those actions to be mutually exclusive when they cannot be done together for sure. So A1 and A2 requires P, A1 requires not P. Okay? I'll mark them mutually exclusive. That's it. I won't do any propagation. I won't do anything further. Just mark things that can't be done together, statically done together. They are called static interferences. I'll mark them mutually exclusive. If I just mark a couple of those actions, all those actions mutually exclusive, and sit back and see the fun, what happens is planning graph, relaxed plan computation will say, oh, I have these actions, I can use them. I have these preconditions, I can use them. I have these actions, I can use them. Oops, these two actions cannot actually work together. Maybe there are different sets of actions. I'll try all sorts of combinations. None of them will work. Then I'll come back, I'll come back, I'll come back. There is actually a beautiful postscript animation of graph plan algorithm. And it looks exactly like what I just showed you. It doesn't have my cuteness, but it has this crazy thing going up and coming back. Okay? And so, the minimum, as soon as you throw in just the static interferences of the actions into the planning graph, then just computing a greedy relaxed plan. When you do greedy relaxed plan, you already said, I don't care about the cost. Just make sure it's not infinity. That's how you're saying. Just make sure it's not infinity. It turns out that for normal relaxed plans, that means on planning graphs without mutual exclusions, computing a greedy relaxed plan doesn't require, probably is not going to require backtracking. If you want optimality, then you need to do branch and bound. That's why you will wind up coming back and looking for other other relaxed plans that might be better than this, until you have proved using branch and bound that you exhausted the space. Then you stop. But if you just want satisficing, you never have to backtrack. But with mutual exclusions, even with satisficing, you have to backtrack. Okay? So in fact, what graph plan does is finding relaxed plans on a planning graph with static interferences marked. Now what then is it doing? When apart from just marking the static interferences, it also propagates additional mutual exclusions. What is the advantage of that? The advantage of that is, if you were going to fail here because of choices you made here, and if there is somebody who's going to tell you, you're going to fail right now, it's great. You hate your parents for telling you that, because you're waking up, at 8:30 and your school starts at 8:35, I think it's not going to work. And you look at the parent and say, why are you wasting my time? And let me execute it and find out that it doesn't work. But actually, I'm doing you a great service, right? Your parents are doing you a great service because they're giving you look-ahead information. Okay, and the mutual exclusion propagation propagates what was going to haunt you much later in your search. It propagates that information higher up. So the search can now kill a failing node before the failing node becomes exponential number of other failing nodes, each of which have to be individually killed. Okay? So, we'll stop here. We'll do the rest of the negative interactions discussion and landmarks heuristic next class. And landmarks you're going to discuss mostly.